Hello, welcome back to, we want to set that? Welcome back to our next video, conjugate acids and conjugate bases. You know what acids do for a living? They give away their acidic hydrogens. They give away their protons. So, and when an acid gives away its acid hydrogen, then we call it a conjugate base. When an acid loses a hydrogen, it becomes a conjugate base. For example, this is acetic acid. A little tricky because the H is at the end. Acetic acid is just vinegar, right, nutrition majors? So when an acid loses its hydrogen and we're left with this, what you're left with is a conjugate base. And a clue that it's a base is that negative charge. It's not always going to be there, but when you see it, you know you've got a base. Now what a base does for a living is accept an acid hydrogen. When a base gains a proton, it becomes a conjugate acid. For example, if the base is the acetate ion CH3COO neg, and we add a hydrogen, it's starting as a base. If we add a hydrogen to it, now it's called a conjugate acid. Another example, here's a base, ammonia, NH3. If it's a base here, and we add a hydrogen to it, now we have 4 hydrogens, and since this is positively charged, notice we go from neutral to positive. Now this NH4 plus is a conjugate acid. So let's look at some more examples of where we're identifying conjugate acids and conjugate bases. So if I gave you this, N2H4 plus C6H5COOH yields C6H5COO negative plus N2H5 plus. Oh my God, you don't know this, you don't know, is this an acid or a base? Is this an acid or a base? Well, a clue is, anytime you see COOH, this is an organic compound, that's why you don't know it. Anytime you see COOH, it's telling you, I'm an acid, that's a carboxylic acid. So one of these is going to be a base, and one of these is going to be an acid. Nitrogen, no, I'm not even going to say that. So, this is going to be our base. If this is the acid, this is the base. There's the logic. It's an acid-base reaction. So, now if this starts off as a base, what happened to it over here? Did it gain a hydrogen or did it lose? Since this base gained a hydrogen, see now we have 5, then this base became a conjugate acid. We know that this is a conjugate base, don't we? We know it's a conjugate base. We know it's conjugate because it's on the right side of the equation. We know it's a base because it's got a negative charge. So what happened in between here and here? We lost that hydrogen. We went from neutral to negative. When you lose a hydrogen from an acid, it becomes a conjugate base. Let's look at another example. H2O plus HClO makes H3O plus ClO negative. Oh my gosh, I don't know what's what. Well, there's a tip-off that that's an acid. It's got that hydrogen in the front of it. Remember, positives and hydrogens tell you something's an acid. Now, so this is going to be our acid. And if this is our acid, then the water has to be a base. Water can either be an acid or a base, which gets tricky sometimes. When you're comparing 2 acids, assume it's an acid. But in this case, since it's with an acid and having a reaction, we know water is the base. So what happens to this HClO when we move to the other side? Can you see we lost a hydrogen? When an acid loses a hydrogen, the compound it becomes is a conjugate base. Right away, we know this is a base. What happened here? We went from 2 hydrogens to 3 hydrogens, so our base gained a hydrogen. So if this is a base, this is its conjugate acid. And you're going to need to know all of this in some future things that we do, so don't slough it off. Let's do one more example. If I gave you H2O plus HCN yields H3O plus CN minus. Just for fun, let's go backwards. We don't always have to start on the right if we're not sure. What do we think? We see this positive, so we know it's on the right, so it's a conjugate. And it's positive, so what do you know? If it's positive, it's a conjugate acid. If it's negative, it's a conjugate base. Now go backwards. What does this look like, H3O plus? It looks like this. If this was an acid, this started off as base. So in this example, water is a base. Let's go backwards from here. This is a conjugate base. Right away, we know this looks like that, but with a hydrogen, so this is our acid. Remember, only acid, only base on the left side, only conjugate acid, conjugate base on the right. Okay, so we're done with this topic. I'll see you on the next video.